There are three different types of, well, back that up. We categorize things in science. So if we're thinking about solids now, there's two basic kinds of solids. There's crystalline solids and there's amorphous solids. A crystalline solid has a pattern to how its atoms or molecules are arranged. An amorphous solid has no pattern like that. Amorphous means without shape, so shapeless. So that's the big categories, crystalline and amorphous. The crystalline solids then can be divided into three different categories, and these are based on what the individual units are that compose that solid. So I'm going to try to be brief about this because I tend to spend too much time on this, and it's just really, it's not that hard to understand, and it's not that important. So these are the categories. We've got molecular solids, and those are composed of molecules. Okay, ionic solids are composed of ions, so cations and anions. Those make formula units. Atomic solids are composed of atoms. It's just not that hard, is it? And then their melting points will be different because of that. So let's talk about these real quick. So molecular solids contain molecules. So what holds molecules together? Well, intermolecular forces. We've got dispersion forces, dipole forces, hydrogen bonding. These forces are relatively weak, and so molecular solids tend to have low to moderately low melting points. So some of them are going to have really low melting points, and others are going to be just kind of, medium low, but generally low. Ionic solids are things like table salt, sodium chloride, calcium fluoride, anything that's an ionic compound. What are ions held together by in a solid? They're held together by ionic bonds. An ionic solid is actually just, you could think of it as one giant molecule. So you've got sodium chloride, sodium chloride, sodium chloride, sodium chloride, sodium chloride ions. And they're all attracted to each other, and there's no little units. There are no molecules like there are in a molecular solid. Well, these ionic bonds are very, very strong. They are the strongest kind of bond. And so an ionic solid, being all of its particles held together by these really strong forces, tend to have very high melting points. So you probably didn't know that you could melt table salt, but you can melt table salt at 801 degrees Celsius. It's really, really high. So most ionic compounds have very high melting points because the forces that hold the ions together are very strong. Atomic solids have atoms. What are atoms held together by? Dispersion forces, right? Just those really, really weak dispersion forces. Some of them, like the metals, have some other things going on, and I think we'll talk about those later. But the melting points for atomic solids vary widely. So, because we look at the periodic table, and a lot of them are solids at room temperature. We've got two liquids, but then we have some gases, too. So the gases have to have low melting points, right, if they've already melted and boiled at room temperature. So this is a related table that talks about what's holding these things together. So this is looking at atomic solids and dividing those up. And the atomic solids are going to be held together by three different types of forces. This one is the one we kind of mentioned, called nonbonding atomic solids. This is where we just have those dispersion forces, like with helium and neon and those sorts of elements. So dispersion forces are really, really weak. These guys are going to have low melting points. We can also have covalent solids, where the atoms are covalently bonded together. A covalent bond is a lot stronger than those dispersion forces. And so these are going to have higher melting points. Examples are silicon and diamonds are also covalent solids. carbon atoms that are held together by covalent bonds. So a diamond is really just one giant molecule. And then we have metallic atomic solids. These are held together by metallic bonds, and these have variable melting points. Some of them, like mercury, is a metallic compound, and it's not compound, element. It's a metal, and it has a low melting point. It melts below room temperature. Some metals melt at, you could melt them in your hand. I think gallium is one of them. And others, it would take some serious heat to get them to melt. So metallic solids, their melting points are all over the place. So covalent solids, covalent atomic solids. An example is diamond. These have covalent bonds that are holding the atoms together. So these really are giant molecules, but all the atoms in them are from the same element. So they're kind of weird. There's not a lot of them. But diamonds, they're estimated to melt at about 3,800 degrees Celsius. That's an estimation. I don't know that anybody's actually done that. But in a diamond, you have carbon atoms that are bonded to each other. And so the atoms in a diamond are the same as the atoms in the graphite of your pencil lead. And yet they're very different, right? Your pencil lead is, and by the way, pencil lead has no lead in it. Okay, it's a common misconception. The Romans learned that lead is not a good writing substance because it poisons you and makes you crazy. So we still call it pencil lead, but it has no lead in it. It's graphite, it's carbon. Your pencil lead is soft and black. A diamond is clear and very, very hard, and yet composed of the same atoms. And it just has to do with how the atoms are attached to each other. Non-bonding solids are just held together by dispersion forces. And so they're going to have low melting points. The diamond melted at 3,800 degrees Celsius. Xenon melts at minus 112. It's a big difference. It has to do with the forces of attraction between the particles. Metallic solids, all over the place in terms of their melting points. So mercury melts at minus 39 Celsius. Iron melts at 1809. Really, really high. So what is it that's holding metals together? It's not any of those intermolecular forces we talked about. They're called metallic bonds. And the simplest way to describe it is that you have positively charged ions in a sea of electrons. So we know that metals like to form cations. And so iron will form +2 or +3 ions. And then what happens with those electrons? Well, essentially, if you think of the iron atom as being, like a household, so mom is sending 2 of the kids out to play. Just go outside and play. And so the kids are running all over the neighborhood. So there's all these electrons running around, but then you have these positively charged ions in there, and they are attracted to the sea of electrons, and so it all holds together. It's really hard to understand. So it's just positive ions in a sea of electrons. I'm not going to really quiz you on that. Okay, well, this would have been good to look at. This is a picture. So each atom in this example is losing 1 electron and makes a +1 ion. So there's an electron out here. So we've got 1 electron from each of these, and they're just kind of milling about. And that's why metals can conduct electricity. Electricity is a flow of electrons. Well, in this situation, these electrons can move. This electron, maybe came from this atom, but it could move over here. And then another electron will move over to take its place. And so the electrons can move, and that's electric current. So what should you be able to do? You should be able to answer questions like this. Identify each solid as molecular, ionic, or atomic. Do not overthink this. So let's start with C. Do you think C is composed of atoms, molecules, or ions? It's just krypton. It's an element, right? So elements have atoms. This one's atomic. So if there's only one element, it's got to be atomic. What about this one, calcium oxide? We learned how to identify molecular and ionic compounds back, I think, in Chapter 5 when we talked about nomenclature. We look at the first element. Calcium, is that a metal? Yeah, it is. Okay, this must be an ionic compound. If it's an ionic compound, it's composed of ions. It's an ionic solid. See, that's not that hard, is it? NH3 is nitrogen and metal. That's the word I was looking for. Is nitrogen a metal? No. Is hydrogen a metal? No. But they're not the same, so this isn't an element, it's a compound. If it's not ionic, it's not atomic, it must be molecular. So this is a molecular solid. Okay, that's all you have to do for questions like this.